Okay, so I'll try to explain correlation coefficient using this example, right? So if you're given this set of data, say you have X and Y, and you want to know the correlation between X and Y. Now, there are things you need to calculate, right? You have to recall the formula for R, which is you have N, then summation of XY. So definitely, you know, you're going to calculate XY. So I'm going to have XY, right? And then we have minus, you sum X and you also sum Y, right? So this, the square root of N summation of X squared, then you have summation of X, then you square it. So I'm going to sum X here. So we have total. The total is always the sum, right? So here, this should be 15. To do this accurately, this should be 417. Then this one is just square it. So you're going to have 0, and you're going to have Y squared. So from this formula, we're not done with this formula. So we also have some other component, like you have to do same for Y. So you have Y squared. Then the sum of Y all squared. So these are what you're going to be calculating. So in our case, I should square this out. 1, this will be 4. It will be 9, 16, 25. So what's this one? What's the sum? The sum is going to be 55, right? This 20, 25, 45, 1, 2, 55. Look, and if you square this, we're going to get 3639. This should be 4761. 5321 9, then 5184, then 3600, 6400. You also get the sum. The sum is around 29,243. Just sum it. Then next we're going to be having which quarter? This XY, right? We're supposed to have XY. We have this, we have this. We have this, so we're left with X and Y. So this is going to give me 0, this multiply this, right? So for that XY, let me change color. So here we have 69, then 46, we have 216, then 240, and 400. You can verify all this, then you substitute into the formula. So our R basically will now become, what's the total number? The number here is 1, 2, 3, 4, 5, 6. So we have 6. Summation of XY, which we have here, 1071, minus summation of X, we have it over here, 15. Summation of Y multiplied by 417, and you take the square root of what you have. We have 6 into if you square this, what I'm going to get, summation of this, which is 55 over here. Summation of X squared is it. We have it here. So summation of Y squared is here. So this will now have 15 all squared, right? Now 6 again into Y. Y is this there. So we have 6 into 29243, right? Then minus 417. That we are going to square this. Good. So if you do this properly, we're going to get 6426 minus 6255. So here, the denominator, you're going to get you can verify 255, right? And you're going to get 175,458. Is that correct? Five eight minus 173,889. Now, this guy, multiply this guy also, right? So this same guy over here should be the one multiplying this one over here, everything over here. Good. So if you do your calculation properly, you're going to get 171 upon the square root of 105 multiplied by 1569. So this should simplify to do it properly, approximately 0.4213. Right? So this is your R. Fantastic. And then we can also obtain the equation of the line. Equation of a linear model regression line, right? Like we said, formula is always A plus BX, but we can obtain B by using N multiplied by the sum, right? The sum of X, Y, and we'll now sum Y and X, will multiply it, X, and we'll sum Y also. Then this should be divided by N summation of X squared minus summation of X all squared. So we can obtain B. To substitute, we have 6 into 1071 minus 115 multiplied by 417, which is here, right? So we divide this by 6 multiplied by 5 minus 15 squared, which is the summation of X. So if you do this using your calculator, you should have like 6426, which you should verify, but that's the general idea. 3 minus 22, 5. This should give us 171,105, which is approximately 1.6286. So from here, we can easily also obtain our A, because A, remember, A is always obtained when you have B, because A is summation of the Y upon N, which is 6 in our case, minus B, which we have obtained here. Then we sum X divided by N, because it's just 6 in our case. So we have for A, 417 upon 6 minus the approximated value we have gotten for B, 1.6286, multiplied by 15, which is the summation of X over 6. So it's straightforward. So we're going to get, at the end of the day, 6.69.5 minus 1.628. Then multiply it by 2.5. So this should be approximately 6.65, right? 0.4285. So your regression line will be 65.43 if you approximate this, n plus 1.63x. That's if you approximate this also. So that's that about that. So if you have any question, you can always put it comment section. See you guys in the next class.